Okay, so I think we are live. We wait for others to join and check meanwhile. So people who have joined, just let me know in the chat if you have joined and if you're able to see everything. Yeah, cool. So people who are joining, please just drop a hi. Gonna wait for 2 minutes and then we are gonna start so that we can make sure that everything is clear and you are able to, like, there is audience and you are able to hear and basically see everything that is not required. So today we are going to learn about t-test, everyone. Pretty sure that you have understood about the first two classes, the hypothesis testing as well as the z-test, right? So today we are going to learn about t-test. And of course, I'm going to do the questions with you as well. And we are going to see that exactly how it is done, right? So everyone who has joined, just drop a hi or anything in the chat. If anyone has any doubt as well, please make sure that you ask the same, okay? Good evening, Prahlad. Happy to see you there. Hi, Rohan. So let us wait around, I would say, 5 more minutes and let others join. Meanwhile, I will start sharing my screen. So Pranad, Rohan and everyone else, just let me know if you're able to see that and everything is fine with respect to that. Cool. So let me use the one which is normally asked. Yeah, I think this works. So again, this class majorly will be questions only because the best way to understand about these hypothesis testing, test and everything is by doing questions. Okay. So I see the strength is still increasing. So everyone, let me just drop a hi or something in the chat so I'm aware that you have joined. So we are waiting just 2 minutes. Now, of course, just let me meanwhile cover this thing. Again, just give me a minute. Okay, just a second. I'm coming back. People who have joined, Prahlad, Rohan, can you just let me know as well if my voice is fine? I'm using a microphone today, so for better audio quality. I hope this is fine and better, right? Or like normally it is, I would say, audible. Cool. So just a minute. Just. Okay. So yeah. Cool. Thanks for the confirmation, Prahlad. So I see count is increasing. Meanwhile, let me know the different ways to learn on this stuff. So Yeah. So the very first one, of course, everyone is on the iNeuron website. Like I say this first because once our classes are complete, okay, and let's say if you're not able to attend any class from starting or any time, you have the, I would say, best way to learn on that stuff, and that is something which we are aware of. One second. Yeah. So to understand on that, everyone, we can just go on iNeuron. You can just, I would say here, hypothesis testing. You can search that, or you can explore the courses and just see the one with my name. Right? Let me search hypothesis. There you go. Yeah. So this was the one. Okay. Now already, if you are enrolled, logged in, you are going to see all the previous classes here. Okay. Let me share the link with you as well. Yeah. So if you see here, multiple things are there, everyone, which of course will be very helpful to you all. The first class, the second class, assignment, quizzes, everything is there, which you can use and test your, I would say, learning as well. Many questions might be there, which will force you to basically, I would say, search as well. Okay, search the internet and everything. So of course, that's going to be a good learning. So assignment, quizzes, right? The classes which we have taken, this all is available to you. Okay, so please make sure that you sign up for this particular on the iNeuron website so that it is helpful in your learning. The next thing is, of course, where we are taking it live as of now, the Zoom, the YouTube, where you can take the classes live. And that the reason we are going live on YouTube is because we want to make sure that we are able to help maximum of the learners and we are able to reach everyone. Okay, so that's the, I would say, way to take these classes, everyone. So first is iNeuron, okay, as a proper course, and second is your this YouTube for live classes. Okay, and one more thing, everyone, we are coming up with lots of courses. I personally am also going to take the course on full stack data science. Okay, so recently also took this course where I was helping students with data science interview preparation. So many students have gotten the job, or they're in the I would say, process of applying for jobs, as well as, in midst of many interviews. So I've shared multiple stuff here with respect to resumes, how to basically present your project, how to make sure that you have a good profile. All that has been shared, and that is actually helping a great deal to many students. Okay, so please make sure that you check out all the other courses as well. Okay, we are running good discounts so that students can learn the same. And this is the basically link where this is already the number where you can also connect us for the best prices. Okay, we are coming up with lots of new courses on Gen AI, as well as proper data science and everything. Right, so please make sure that you use that. Full stack data science is there as well, which we are going to use. And of course, I'm with my experience in the industry, working at Goldman Sachs, Oyo Rooms, Mindtical. So that is what you will be learning as well. Right. Cool. Then let us move forward, everyone, and let us start with today's topic. Anyone has any doubt before I move forward? Anyone has anything which they want to ask? Anything which is not clear? Anything which they would like to discuss? Or are we good to move forward? So just wait, just taking a couple of minutes. If anyone has any doubt, let me know. Any doubt, anything which is not there clear, I will help you to clear that. Hope you have done the last classes. You have seen the recordings, okay, on YouTube, or I would say on by signing up on the iNeuron. Okay, so please make sure that you do that. Great. Then, if no doubts are there, then let me move forward, everyone. So today we are going to do, I would say, t-test. Okay, in the last class, I can just quickly help you revise the last class as well. In the last class, we did the Z test, and p-value I'm going to teach you today only. Should be fine. Okay, so you see so good of a notes, right? So yeah, beautiful notes. You're going to get these notes. Okay, Z test, and you can use these notes to basically revise anytime before your interview or any, I would say, particular test. So Z is a statistical test and everything we have given. Then confidence interval. Pretty sure that this multiple pens and writing should be helpful to each and every one of you. Then point estimate, exactly what is happening, right? Then we did some questions to understand about these point estimate and how they are done. Then I told you about this range of error and everything. Then we saw another question, which was very much, I would say, in line, or which was helping you to understand this stuff, right? So on that note, we basically did all of these stuff, and I showed you that, okay, exactly how you're getting the answers. Okay. Now let us move for the t-test, right? Sir, please take one more question Z test. Sure, Prahlad, let me just cover the T test first and then I'm going to take the question. I hope that is fine. I hope that is fine. Because I will be telling you as well that how, where exactly the T test is used, Z test is used, that all is required. Okay? Chalo. T test. Okay, so let me just now start with this theory, everyone. So T test is actually again a T test. Okay, is a statistical test only. Okay, it is also a statistical test. It is very close to your, I would say, Z test. Okay, statistical test used to compare. Okay, used to compare mean of two groups. Okay, mean of two groups. Now you have to understand this one thing, that Z test was also helping us do the same, but it is used. It is used when sample size is small, okay, generally less than 30, and sample standard deviation is given. Sample standard deviation is given, right? So this is where we use t-test, everyone. I hope that is clear now. Anyone has any doubt here? Anyone has any doubt in this thing? So we have around 10 people. Let me know if anyone has any doubt. So of course things are going to be more clear once we do the questions. So this can now again be actually applied in a similar manner. Let's say if you have a bag of chips, right? So let's say you have the overall, I would say, information about the sample. Let's say you have 25 this sample of basically 25 numbers, and you, let's say this says that it is 50 gram, and you found out that this is 48 gram, and you also have the sample standard deviation. So sigma of sample. Okay, it is normally denoted by S, right? That is where you are going to apply the t-test. Okay, that is where you are going to apply the t-test, everyone. I hope this is clear. The understanding is clear. Yes or no? Anyone has any doubt? Now, in a similar way, of course, this can be used to compare two different types of drug as well. So there are, I would say, one group, two group t-test. Like two groups is when you're comparing two groups, okay, where the sample size is small. One group is, let's say, when I am, let's say, part of a 25 people person group where we are doing some exercise. And let's say after 10 days, okay, so first you take the all the metrics today, weight and everything, and then let's say after 10 days you again measure that, and you see that okay, if there actually been a difference, exactly what is happening, all that is where t-test can be used, because we have the information about sample, right? So drug A, let's say, is 55% effective, and drug B, let's say, is 50% effective. So on all these use cases, basically, that is where we use these t-test. Now again, this is very much, I would say, close or equivalent, I would say, to your z-test. So what happened? Okay, and basically to understand that why we are, where we are going to apply the z-test and t-test. So let us, this is the table, everyone. So z-test and t-test. Now pay attention, everyone. When n sample size is greater than equal to 30, okay, when sample size is greater than equal to 30, and population sigma, okay, or sample sigma is given. Sample sigma is given, right? So if the size is greater than 30, you're going to apply z-test only. Okay, doesn't matter if it's a population sigma or sample sigma. But when the size is less than 30, then if you have population sigma, you're going to apply the z-test only. Okay, so it will be clear if we have the sample sigma and your n less than 30. So if population sigma is given, population standard deviation is given, we are anyway going to apply the z-test only. Okay, it doesn't matter what the sample size is then. I hope that is clear, everyone. Yes or no? I hope that thing is clear. Can anyone tell me if any doubt is there? If anyone is having any doubts? Anyone, anything which is not clear? Just let me know in the chat. I'm actively looking at the chat, because of course it is not going to be useful if you are attending this live and not basically asking your doubts on the spot. It will kill, I would say, overall benefit of these live classes, right? So if anyone who has any doubt, please make sure that you ask that. Now, before we move to the question, there are actually three types of t-test which I want to explain you. Three types. First one, okay, everyone. First one is your one sample t-test. One sample t-test. So what happened in one sample is that it is basically comparing. It is comparing, right? Let me write this in different pen. Compare sample mean to the population, right? We just have a sample. So let's say again the question can be very much same. Like let's say if you're living in a society of say 5,000 or 10,000 people, then you want to get the average height of the society. Let's say you get 25 people randomly and get their height. Take the average, and overall that thing is going to help you, right? So that is your one sample t-test. Now next is your actually two sample t-test. Sorry, independent two sample t-test. Independent, okay, independent two sample t-test. So here what happened, like as I give you the example of these drugs, right? The samples in itself are independent with each other. Okay. So compare mean of two independent sample. So let's say this can be like, let's say you are comparing this average height of, let's say, some society. If you take 25 people, one society is in India and one is in America. Okay, so they are just independent with each other, no dependency whatsoever. Okay, compare mean of two independent samples. And now the third one actually, what it says is second dependent, or I would say paired, these paired, right? Sample t-test. So here now what is going to happen, everyone, is that the samples are basically paired, right? It is exactly the example which I was giving. So let's say 2 days after, I think the 23rd day is a yoga day. So let's say I do yoga for 10 days. You get all my vitals, weights and everything along with other 24 people. You get the vitals, weight and everything. You calculate the average on before 10 days. But after 10 days, you again calculate the same weight, height and everything. Okay, so this is basically used to compare means of single group or of same group at two different times. At two different times, right? So this is what your paired sample t-test is. I hope everyone is aware, like clear with this thing. Prahlad, Rohan, everyone else who are attending. So we have around 7 people, yeah. So it would be helpful, people, if you are just commenting the same. That will be a lot helpful. Okay. So now let us see some application of the same as well. Real world example. Okay, let's say a scientist, okay, want to test if a new drug. Okay, so I'm gonna write this as well. A scientist want to test if a new drug, okay, let's say if a new drug, right, it is basically having an effect, has a different effect than placebo. So I will tell you how basically this medical trials are done. I think because placebo might not be clear to a lot of people. So there's an effect which is known as placebo effect. Okay, let me show you that. Okay, yeah, placebo effect. So this is actually used in lots of, I would say, clinical trials. Okay, so placebo is actually a substance or treatment which is designed to have no therapeutic value. So let's say, okay, let's say you are struggling with something. You're struggling with, let's say you are having a fever, right? Now to actually make sure that your, I would say overall the drug which I have made it works. Okay, what is the way for that? One way is that I will be dividing the group. Let's say dividing the group into two separate groups. Okay, two, I would say, non-existing or non-overlapping groups, and then one of the group. Okay, so let's say we have some group of people, right, like this. I'm going to divide into two groups. Let's say they all are having fever, right? One I'm going to give the medicine, the real medicine. One I'm going to just give a let's say a fake medicine, which is known as placebo. Now, if the medicine is actually working, it is going to bring out, I would say, positive change in this particular group, right? And if it is not working, it is as good as a placebo or as some random treatment, or I would say just a normal tablet, right? Tablet just does nothing. It's going to not have an effect, right? So that is how normally these medical trials are carried out. And of course, all these tests, right, Z test, T test, they have a very good, I would say, use there, because we have all the means of different things. Like, okay, what is the mean temperature of this thing and what is the mean temperature here? Then we can actually make sure that if there is a significant difference between them, and if there is a significant difference between them, then we can actually say that yes, the medicine is working, right? So in a similar way, that is why basically it is used. Now, of course, here we are going to use independent two sample t-test because these groups are not related to each other, right? And that is how it is used. And of course, based on these particular things, different formulas are there. So we are going to do the question, and there I'm going to show you the this formulas as well. Okay. So let us move to the question now. Anyone has any doubt before I move to the question? Anyone any doubt? Anyone has any doubt before I move to the question? Any doubt? Anyone? Okay, let me know in the chat. Let me meanwhile write the question. Okay. So question: in a iNeuron assignment test. Okay, in an iNeuron assignment test, a sample. So let's say you all are taking my classes. A sample. I take a sample of 25 of students in this. A sample of 25 test takers. Right. 25 test takers have a mean of say 520. Okay, I'm taking the values from the last only, the question which you did, and a sigma of 80. So now you have to understand one thing, everyone. This is your sample mean, and this is now your sample sigma. We are not sure of population sigma, right? This is a for these 25 test takers, right? We have the sigma as well for them. So what we have to do, we have to similarly the question which we did just for our Z test, we have to do a similar question, construct a 95% confidence interval, okay, confidence interval around mean. Now I'm pretty sure that this should be clear to a lot of you, the question, because it is very much same. So let me show you the parallel question which we did in the Z test. Okay, so pay attention everyone, the parallel question, what it was. Okay, the one, yeah. See, on an aptitude test of a company, a sigma population, this time we were given sigma population is known to be 100. A sample of 25 test takers who have a mean of 520, right? We have to construct a 95% confidence interval around mean. This time we just know the sigma sample. Now, as I told you, if the sigma population is given, this doesn't matter. This overall, I would say 25 test taker doesn't matter. So what we can do is we can just directly take this, I would say this thing. We can just directly apply the Z test. But because sample is given, then we check the sample standard deviation is given. We check the sample size as well. And sample size, because it is in this case less than 30, we are going to apply the T test. Each and every one of you, is this thing clear as well? First tell me this, then only I'm going to move forward and solve this question for you. Is this thing clear as well? Can anyone confirm me if this thing is clear? Anyone has any doubt, anything? So people who are seeing this class around, we have 5 to 10 people. Okay, not really sure how I dropped. But anyway, I hope this thing is clear. Again, teaching you with a very good concept by telling you the concept first and then coming to the theory first and then coming to the practical. Okay, so let me know if any doubt is there, anyone, and we are going to see for that, right? So now let me solve this question for you, because many things in the formula I have to tell you, and then next question you're going to solve yourself. Okay, so let us first write in these type of question, let us first write what all we are given. So n is equal to 25, we know that. X bar, which is the sample mean, we know that it is 520, and we know the sigma of sample as well. So sigma of sample we write with S as well, and it is equal actually to your 80, right everyone? So this is what all we know. Now population parameter, right? So that is what we want to connect now. No? That okay, till which mean value we are going to actually take this to be a 95% confidence interval. Population parameter, as you all know, it is given by point estimate plus minus margin of error, right? Margin of error Now, for your, I would say this thing, for your t-test, okay, the margin of error is actually given by, so this is going to be x bar plus minus t-test margin of error. So this TMOE, the formula is actually a little bit different here. It is T alpha by 2, okay, into S by root n, S by root n. So I think now the values are clear to each and every one of you. Alpha is going to be 0.05 because my confidence interval is 95.95. Each and every one of you, can someone confirm if this is clear as well, how we have written all these values? Then only I'm going to move forward. How I have done this part of calculation. If no doubts are there, then only I'm going to move forward, because it is not helpful if you're not understanding this stuff. I'm taking it very slowly, explaining you each and every step. So I hope this is clear. It is going in line with all the stuff which we have discussed in the first class as well, that we first write down each and everything. This question is not for hypothesis testing, but the understanding is still the same. We are in a way calculating the, I would say, particular lower and upper fence, post which null hypothesis is going to get denied, right? So anyone can write if any doubt is there, anything, if everything is clear. Okay, let me know in the chat if anyone has any doubt. Okay. So with respect to time, I'm just moving forward because I have to make sure that I explain this question and also clear your, give you another question which you can gonna do yourself. Nice. So let's do this. Cool. So see everyone now. In t-test, we need to actually find one more thing as well. We need to find, and let me show you that first. Actually, that is going to help you. Okay, so just like we had a table, for, I would say, your z test. Okay, now again, clear. Okay, thanks Rohan. So we have a t test table as well, everyone. T test table. Okay, let me see this table. Now the way t-test table is actually coming, this one tail, two tail, again I'm going to show you this as well. I think I've shown that, but I will check, else I'm going to explain you that. Now this t, this is clear. I think this, the t, this whatever is written here, I think we have to go for t 0.05. Okay, so, or t 0.95 because it is on the other side, right? So that is how we have to see that. It is either t 0.95 or t 0.05, right? So that is why we are seeing it. But there is some other thing as well, df, degree of freedom, right? Degree of freedom. So let us now understand what this df basically is. Okay, so this is also something which we have to find in our t-test. So we need to find degree of freedom for our okay, particular t-test, and it is used actually in a lot of other tests as well. Okay, so I think it is required in chi-square and f test as well. So we are going to see once we learn about them, right? And many other statistical tests are there where degree of freedom is used. Now it is actually given by sample size -1. So this implies it is going to be, 1 second. Okay, n -1. In our case, n is basically, if we see n, what is n? N is 25 here. So we are going to take n -1, which is going to be 24. Right? So this is what we take as degree of freedom. Right, everyone? So now we have degree of freedom now because we have degree of freedom. Okay. And what we are also going to do is t alpha by 2. So t alpha by 2, now if you understand everyone, okay, alpha we know that it is 0.05 and alpha by 2 will be t 0.025, right? 0.025. So now we have the values, we have everything here. This is 0.025. We have the degree of freedom as well. And let us go back to the table again. If you see here, actually this 0.05, two tails, right? So this is actually, let me explain a little bit about these two tail and one tail test as well. So when we make our, I would say, distribution of samples like this, when we want to calculate, like for example, in this we want to calculate the lower and the upper fence, both of them, right? This is what we want to calculate. When we want to do stuff like this, there, it's a two-tail test now. If you want to pay attention, it's a two-tail test because you have two tails here. This is the first tail and this is the second tail, right? So that is what two-tail test basically says. Now, if we, let's say, just want to know if, let's say, your mean will be greater than this particular value, then it becomes a one-tail test. Okay, So on the basis of that is where we have to take this thing, right, everyone? In this example, it is a two-tailed test, okay, and this is 0.05. This is 0.05, right? So for a two-tailed test and 0.05, and I think we have the degree of freedom as 24. We have the degree of freedom as 24, and you are going to see that how is it coming. So it is a two-tailed test, right? So one second, let me show you this in another way. Yeah. So how to find this value is very important again. So see everyone, it's a two-tailed test. We have made sure of this, that this we know. Let me change the color to red. It's a two-tailed test. Now here in this two-tailed test, the value we have already see that it is 0.05, and degree of freedom we have calculated to be 24. Now let us go forward and see where they are meeting. So this is our value, everyone, 2.064. Okay, I hope this finding out the value is also clear to you. We got use the degree of freedom. What test we were having, two tail or one tail, the way I've explained you, I'm going to explain you this in a little bit more depth. And again, then basically, if what's the value of our alpha, right? So that is how we can use the same. Let me actually just copy this and make sure that I'm pasting this as well here. Yeah. So in this way, we know that the value, okay, of our t, the value of our t 0.05, t 0.025, right? It's gonna be 2.064, right, everyone? 2.064. Now, if it's 2.064, we can calculate our margin of error. So if you remember, margin of error was t 0.025 into s by root n. Now, s was, if I remember, it was 80. Root n was root of 25, which is going to be 5. Okay. So let us now calculate this. 2.064 into 80 by 5. This is going to be 16. And I can do this calculation with the help of calculator. 16 into 2.064. It's 33 point that, everyone. It's exactly 33.024. Everyone, I hope this thing is clear to you as well. Anyone has any doubt here? Anyone has any doubt here? Anything which is not clear? So it's actually gonna be 33 point, okay, 024. Now my mean was 520, right? So if I want to minus this, so 3520 minus 33.064, 486.93 or 97, right? So that is what I'm getting. I hope this is clear, everyone. 486.93, I think, was the answer. Okay, so again, we can calculate the upper fence as well. That is something which I'm going to leave on you. That is something which I'm going to leave on you, right? And I hope you are going to calculate that, right, everyone? I hope this is clear. Anyone has any doubt, please ask that in the chat. If anyone has any doubt, please ask that in the chat. Okay, that will be helpful. Now, meanwhile, I'm writing a question which you all have to solve yourself. Okay, so just understand the same. Let me actually first show you this. Let me first show you all the calculations which you have done. Let me actually just quickly revise the question. Okay, so that the next question is easy for you to understand. In an iNeuron assignment test, a sample of 25 test takers have a mean and sigma of 80. Right. So this thing is very important to understand the sample size, mean, and which sigma, which standard deviation is given to us. Now here the standard deviation is given of sample. Okay, so that makes it that we are going to apply t-test because it is 25 as well. We have to construct a 95% confidence interval. The question is very much analogous to the question which we did for z-test. Now population parameter. Okay, we have just written all the things which we know: n, x bar, sigma. We can write alpha and ci here as well, but that is something which I've written here. Then we have the population parameter, everyone, right? Point estimate plus minus margin of error. Okay, so TMOE, T alpha by 2, S by root n. I hope that is clear, each and every one of you. Now we find the degree of freedom because that is required here. Okay, because in the table also we saw that degree of freedom is something which is used, DF. Right? That is how the table is calculated for this thing. Okay. Now see, everyone. Once you have the degree of freedom, we got this value from the table. We got this particular value. I explained you what exactly z test and t test is, right? And here you are going to see the values 2.064. So I've done, make sure that I've explained you this properly live. I've calculated that. Okay, I've not written this somewhere. Or I don't even remember the value honestly. Okay, so table will always be provided to you. Even if a person is asking you this in an interview, right? In an interview as well, you can ask the interviewer for the table. Or you can ask that, hey, this t 0.025, can you tell me the value for a degree of freedom of this? You don't have to remember this table. Okay. Now, once we have this, we calculate the margin of error, and using this, we can calculate the lower fence and the upper fence as well. Okay. So this was what was explained, everyone. Now let me give you another question. Okay. Now let me give you one more question, everyone. Just a second. I think there's a power cut at my end. Just a second, everyone. Let me just quickly check. Seems to be a power cut at my end. Okay. I hope you're able to still see. Okay, so I hope no disruptions were there. Yes, okay, yeah. So glad the UPS for the Wi-Fi router works. So let me now give you a question. A factory, okay, a factory is making chocolate bar. So last time we understood this about the Lay's question, right? So it's a similar parallel question which I made, which have a mean of 50 grams. So let's say you got a dairy milk chocolate of 50 gram. Okay. Now, of course, we are not always skeptical. So you took 25 samples, right? 25 samples and observed mean to be, okay, we have observed the mean to be 49 and standard deviation to be standard deviation to be 2.5. Okay, everyone. So we observed that this basically is overall, I would say, one second, everyone, the power cut is still there. Okay, so we got this as 2.5, right? Standard deviation we got as 2.5. Now, what further basically this is asking us? So first, I hope the question is clear, everyone. Please let me know if question is not clear. So it is the same which you can think of is that you are making dairy milk is there. Okay, we are making this dairy milk. Dairy milk, let's say 1 bar of dairy milk. Okay, so let me just tell you the question. So let us see this thing. Even I am not sure what dairy milk 50 gram. Okay, so 52 gram dairy milk comes in 52 gram, right? You can see this particular thing. But what's the overall, I would say, guarantee that, okay, it is always 52 gram, right? What's the guarantee that it is 52 gram? Or let's say we see this as well. Let me copy this image. Now, what's the guarantee that, okay, it is actually 50 gram, right, everyone? So what we do is we calculate, we basically take 25 samples. Okay, we take 25 sample size of 25 and basically calculate the mean and standard deviation for them, right? And then using this test, we can actually say if actually that is true, what they are claiming, what the Cadbury is claiming, or that is not true. Because we have this sample and we can use t-test there. So I hope you're now getting the usability as well, everyone. Okay. So of course, using these examples, so the usability is clear. Anyone has any doubt in this question? Anyone has any doubt in this question? Now the question here becomes, is the average actually 50 gram? Now see, when this is the question, is the actual average of weight is actually 50 gram, you have to understand one thing. Here, there will be two errors or two tails will be formed. Even when you are getting, let's say, less than 50, some with some confidence interval, of course, that is also a problem. Even if you're getting more than 50, that is also a problem, right? So basically, we are dealing with two tails here, everyone. If you're getting less than 50, that's also a problem. Let's say if you're getting it like normally, let's say the weight is 48 gram or something, or that is what we are getting the mean after this t-test and everything. If you're getting greater than 50, that is also a problem. So this actually is something which is known as your two-tail test, because we are penalizing or we are seeing the error on both the ends. Okay, it is not that we are just fine if it is greater than 50 and not fine not with that. Ideally, in this case, what I think the major thing which you will want to know as a consumer is that if it is less than 50. Now, when the question changes this way, when you are specifically asking if this particular thing is less than 50, because see, of course, if you are getting more than 50, then you're not gonna complain, or you're gonna be that yeah, the company is generous, right? Now when actually it is less than 50, then you're gonna just see one tail. You're gonna just see one tail, and that is what your one tail test is. Now this is a one tail test, because if it is more than 50, you are fine with it. You are fine with it, and based on that, of course, we can choose the table as well. See, one tail, two tail, degree of freedom, everything. So in the one tail, what exactly happens is that you will be not dividing your error. T is gonna be that only, of course, because it is just one tail. We were dividing T earlier. If it was alpha earlier, we were dividing it was 0.05. We were taking it as 0.025 on each end, right? So that is what we are going to do, everyone. I hope this is clear. Two tail and one tail is clear as well. Anyone has any doubt? Anyone has any doubt? Another example is, like, let's say we say that hey, in a college the placement rate is around 88%. Okay, let's say the placement rate is around 88%. Now, what exactly is happening is that, let's say you are called and you do some analysis, you calculate 35, 40 people, you take a sample of them, and you basically do your analysis, and you find out, let's say, the some standard deviation and mean for the same. Now, if the question is that is the placement rate less than 88, then it's a one tail test. If the question is the placement rate actually 88, then it's a two tail test, because we are going to penalize the error if it is greater than 88 as well, with some confidence, and with some margin of error, and if it is more than 88 as well, right? Both the ways we are going to, I would say, penalize them. But if it is the question is it is I would say greater than 88, then just one side will be penalized. Okay, so that is how you understand this one tail and two tail test, everyone. I hope this is clear. Each and every one of you. Anyone has any doubt here? So let us now do one question if anyone has any doubt. And I think, Prahlad, so this is one question which you can solve now. A factory, okay, has a machine. Factory has a machine that fills. Okay, that fills. So we are going to take a very relatable examples. Okay, again similar question. 80 ml of medicine. Okay. So everyone, I hope we this question we have already done, if I remember right, this kind of a question on an aptitude test. Yeah, so this question actually we have already done. That should be fine. So let me just give you another question, everyone. Okay, let me give you one more question. So just a second. Meanwhile, if anyone has any doubt, let me know. Anything which is not clear, please let me know. Anyone who has any doubt, anything which is not clear. Great. So let me give you another question, everyone. The based on again the same thing which I explained, average weight of residents. Okay, average weight of residents in a society is known to be 168 lbs. Okay, let's say you're living in a society, or let's say average weight in a state, it is known to be this much. Okay, now a nutritionist believes this to be false. He say that nahi yaar, it is not the case. But you are saying 168, but I to think that no, it is not the case. Okay. Now again, whenever this kind of, I would say, understanding happen, as a statistician, as a data scientist, we just work on proof. We don't say ki nahi, nahi, I just saw 4 people walking out or 40 people walking out, they all were sick or they all were not that much weight. Maybe those people were walking out from a gym, right? So he take basically, I would say, false. So what he did, he take a sample of 36, let's say, members. Okay, 36 members or individual, and found the weight to be 169.5 with a standard deviation of 3.9. Right, so that is what he find out to be, that 169.5 is the weight he find out with a standard deviation of 3.9. Again, now, okay, we are going to take a very Sorry everyone, I think I got disconnected. 1 second, so there was a just internet issue. Let me just share my screen again. Cool. I hope now it's fine, everyone. Can anyone just confirm me if it is fine or not? It got disconnected in between due to some internet issue. Can anyone confirm me? I hope it is fine now. Okay, cool. Thanks, Rohan. So yeah, this is the question, everyone. Glad it was just back in a second. So yeah, just got disconnected. So this is the question now. Of course, this question. Let us now see exactly what is going to happen in this question. So this is fine. Cool. So see, first we are given. Let us write first what all we are given. Okay, let us first write. And you can also just do this question. Of course, this is very much doable by you all now. N is equal to 36. That is what we are given. We are given the X bar, the sample one, 169.5. Okay. We are given the sample standard deviation as well, right, everyone? We are given the sample standard deviation and we are given nu as well. Nu, I think, was 168. Alpha will become 5% as my CI is 95%. Can anyone tell me in the chat what will be the null and alternate hypothesis? Anyone? Can anyone tell me what is going to be null and alternate hypothesis? Now you should be good to write this null and alternate hypothesis, everyone. Reduce the nip size. I think this is coming out to be a little bold. Yeah. Again, so H naught, your null hypothesis is gonna be nu is equals to 168, right? Because we are assuming everything is fair. Okay, there is no difference, everything is equal and fair. H1 or HA is gonna be nu is not equal to 160, right? Because nutritionist, the question was to discard null hypothesis, right? The question was not that if it is greater or lesser than 168, right? So we just wanted to see if this is the weight or not, right, everyone? I hope that is clear, each and every one of you. Anyone has any doubt here? So this is your normally step, I would say, one, right? Then let us see the next step. Next step, we just make this kind of a graph, right, everyone? So we are making this kind of a graph where we are going to make these spaces, right? Now this is going to be 0.25. This is going to be 0.25, right, everyone? This is going to be 169.5. We have the areas where we are going to accept the null hypothesis. We have the area where we're going to reject the null hypothesis. Can anyone tell me, anyone who can tell me what these values going to be? What these values going to be? Anyone who can tell me? What is this value going to be? Can we calculate the test statistics, everyone? Yes or no? Can we calculate these values? First, tell me this. So if you would have revised the class, this all of you will actually remember only. Okay, so let me open the z-test table. Z-test table. So again, I just want to see where this is cutting the graph. I told you in the last class as well, if this area is going to be 0.975, this full area. So where this 0.975 is, here it is 1.96, right? So this is the value which we had last time as well, 1.96 minus plus 1.96, right, everyone? I hope you remember this thing. Now, next thing, what we all can do, we can calculate Z. What was the formula to calculate Z? Can anyone tell me? S by root n. So this time we are given standard deviation of sample, but we are given standard deviation of sample, but sample size is 36. So that's why I'm going to apply the Z test and not T test. And the test becomes important because the test is going to tell you what these values will be. Right, everyone? Based on Z test or T test, which table you have to refer, that is what tells you. Now, if you're going to apply Z test and I would say it is wrong and calculate the T statistic here, that's going to be wrong as well. Okay, everyone, I hope this is clear. Anyone has any doubt here? Anyone for whom this thing is not clear? Anyone? Cool then. So let us calculate this value, everyone. Z is gonna be, I think it was 169.5 minus 168 divided by S was 3.9 divided by 6. 3.9 divided by 6. So it is gonna be 1.5 into 6 divided by 3.9. Right? So this is gonna go above. This is gonna get calculated and 3.9 below. So let us see this now, everyone. 1.5 into 6, it's 9 divided by 3.9. So the value which we are getting is 2.307. 2.307. Now again, if I make the graph again, if I make this graph, I know that I am cutting on minus 1.96 and plus 1.96. The value which you are getting is actually 2.307. It's going to be somewhere here. Here I'm going to reject the null hypothesis. Okay. And what's the null hypothesis? Null hypothesis is that nu is equals to 168. So the nutritionist is actually right. Okay. This actually is false. Based on the sample, nutritionist has actually solved this thing. I hope that is clear, everyone. I hope that is clear. Anyone has any doubt in this question? Anyone has any doubt? Anyone any doubt? I hope you understood the same thing. Everyone has understood this thing. Yes or no? Anyone has any doubt? Just let me know. Then I'm going to move to p value as well to explain you p value. Okay. Everyone else, I hope you are seeing this value. Pradhat, I hope you are getting for the one question for Z test as well. Na? I hope you are able to see this question. Okay, so if no one has any doubt, let me just quickly explain p value as well. So p value, okay, p value indicates the probability. P value indicates the probability, everyone, okay, of obtaining result. Of obtaining result, right? If we assume null hypothesis to be true, if null hypothesis is true, right? So let us understand this in terms of graph as well. Okay. So see, when we have this graph, okay, when we have this particular graph, we know the area here. We know this area. Now p value tells you the probability. P value tell you the probability. Okay. If null hypothesis is true, okay, then what is the probability? Now, if this probability actually is less than the area, so what is probability? Probability is just, I would say, favorable outcome upon total outcomes or percentage of, I would say, happening favorable outcome, right? Favorable outcome in this case is null hypothesis. If that favorability of null hypothesis is the area or probability of null hypothesis is less than this particular area, then don't you think we can say that null hypothesis is false? Yes or no, everyone? I hope this thing is clear. So we actually calculate p value. So always remember that p value is calculated, whereas alpha significant value is given. Significant value is given, right? Now very much important thing to understand, as I was explaining you using the graph, if if p value is less than alpha, like the probability of something happening is less than the that overall area, overall that value, okay, then we are going to reject null hypothesis. Then we are going to reject our null hypothesis. But on the other hand, on the very other hand, if p value, if the probability is greater than the probability of failing, the probability of area where we are rejecting a null hypothesis, we accept the null hypothesis. I hope the p-value is clear, each and every one of you. What exactly p-value means? What exactly p-value means? Anyone has any doubt here? Anyone has any doubt here? Now let me show you one thing here in this question, in this particular question. Okay, in this particular question, we can actually calculate this as well. Okay, we can calculate this as well. One second. This was the question. Abhishek, do you have any doubt or is it not clear? Do you have any doubt or is it not clear? Can you tell me what exactly is the case? Any doubt or is it not clear? Now see, let me explain you this p-value concept using this question which we just did. So we calculated this z is equal to 2.307. How are we going to calculate p-value from that? Pay attention everyone. Let me just add another page here. Okay, cool. So pay attention everyone. How are we going to calculate this area? See, either we can calculate this test statistic which we have calculated here. Else what we are going to do is, else we will forget this test statistics and basically see that, okay, this is 2.307 and this is going to be negative 2.307. Now, if I calculate the area, if I calculate this area, right? If I calculate this area, which is given, if I calculate this particular area, I can actually, I would say, compare that with the area which is given to, which is given by the significant value. Yes or no, everyone? I hope this is clear. So what I can do is I can divide my area into three parts. 1, 2, 3. Right? Now pay attention. This is minus 2.307. So what I can do is, let me go on this table. Where the z is minus 2.3, minus 2.307, right? So this z value, okay, when it will be minus 2.3, okay, this thing, let me just have this tool, yeah. If this z value, everyone, is going to be minus 2.3, right? 07, right? It was minus 2.307. This is 07. So let us calculate what is the area here. So the area which we are getting, everyone, second 2 point, let me correct, just remove this everything. Just a second, everyone. So this area, it is minus 2.3, okay, 07. So we have taken this full value, right? So now exactly where this is happening is 2.307. So this is the value, right? 0.089. Because if you see, this is 07 and this is 2.3, right? So now I get this particular area. Now I get this particular area, which actually is, which is coming out to be, this area is 0.0089. Right? If the whole area is 1, where the z is minus 2.307, the area is 0.0089. Again, because of symmetry, the area will be same here, 0.0089. And now what I can do is I can add this 1 plus 3. It is going to be equal to 2 into 0.0089. So this is actually my p-value. If we assume this to be true, the null hypothesis 0.0089, it is coming out to be 0.10178. 0.0178. Right, everyone? I hope this is clear as well. Anyone has any doubt here? Anyone has any doubt? And now this 0.0178 is actually less than your 0.05, which is your null, which is your actually significant value. So 0.0178 less than 0.05. It is coming out to be true. And when this happened, what I've told you, if p-value is less than alpha, we reject the null hypothesis. And that is what we have done above as well. See, when we calculate this particular thing here, we have rejected a null hypothesis. So you're always going to get the right, same answer if you're doing it using test statistic or you're using it using p-value. I hope this is clear, everyone. I hope this is clear to each and every one of you. So that is how p-value is used. We calculate the area of our null hypothesis to be true, and of course, if that area is less than that particular alpha, then we are gonna get the answer. Okay, so I hope that is clear, everyone. So we have seen the t-test, okay, one tail, two test, and p-value. So in this particular class today, we have done actually three concepts very nicely, and you're going to get these notes as well. So let me write the agenda here. We have done the p-value, one tail versus two tail test, and very important t-test. As well as we have seen that where t-test and z-test can be applied and cannot. So if anyone has any doubt, just let me know in the chat. Anyone has any doubt which is not clear, I hope you understood the same. You are gonna get these notes. That should be fine. And where you can download these notes, everyone, I hope this is also understood by everyone. So when you go on, I would say this particular hypothesis testing thing, hypothesis testing. So once you go on this particular, I would say page, everyone. Okay, once you have enrolled now here, it is going to take you to the course. I'm not sure why this is slow. Case. Okay, it is taking a little time. Let us wait. Meanwhile, if anyone has any doubt, let me know in the chat. I can clear your doubt. Any doubt if anyone has having. Also, make sure that you are seeing live. If your internet is slow, you might get a little behind. You're not going to be able to hear this, but will be helpful in the next classes. Okay, let me go my iNeuron only. Explore courses. It is running so slow. Yeah, I think we need bigger servers for our website. Okay. One second, everyone. Just let me log in and show you how you can download these resources, because I think these will be a lot helpful to anyone who is seeing these classes regularly. If the website opens, not sure why. Normally it doesn't happen, but yeah. Let me do one thing. Go now. Sign in. Okay, seems like it's working now. Maybe I have to clear the cookies or something from my particular that thing. Because normally, as I said, it normally opens, and you can go on resources here, everyone. And here from here, you can download the resources. So for this class as well, you're going to see the resource here. So that is where you can download the notes, the codes, anything which we are using. Okay. Cool then. If anyone has any doubt, anything which is not clear, let me know in the chat. I'm gonna wait a couple of more minutes, and if everything is clear, then we are gonna close the stream. And I'm pretty sure that it is helpful to you. We are gonna learn again few things in hypothesis testing. It is very difficult topic. I'm trying to make sure that it is very easy to you to understand, and it is used in interview and basically asked in interview as well as in industry as well. So please make sure that you understand that. Yeah, so ask your doubt if anyone has any, and we are gonna solve that. If no doubt in a couple of minutes, then I'm gonna close the stream. Cool. So if no doubt is there, anyone, everyone, let me close the stream, and please make sure that you are actually doing and seeing these classes again. If any doubt is there, you can reach out to me at my email ID as well. I am just sharing my email ID, not this one. Second. Yeah. Sharing my email ID with you as well. Okay. That is where you can just mail me. And yeah, I will be more than happy to solve your doubts or help you in anything which you are struggling with. Okay. Cool then. Thanks a lot, everyone. Let us meet in the next class. Thank you.